Hi guys, I'm just going to do a tutorial using Python to do some linear algebra questions. Aim here is to try and find the determinant of two matrices, the inverses, the transpose of the matrices, their LU decomposition of the matrices as well. And I also need to find, I need to show you that obviously matrix multiplication is not commutative. And as we go along, I'll also put some other properties of matrices like finding the trace, the eigenvalues, and so forth. So what I need to do is I need to load my symbolic package. So what I need to do, the code for that is from Sympy, then import and asterisk. Then I also need to use the Unicode type of printing, so matrices come out in a very neat way. So that'll be init printing. So and use Unicode. Right. So my matrices are going to be for A. I'll assign matrix A as follows. My matrix B will be as follows as well. Right. So what I need to do is now I need to find the determinants for both matrices. So I'll start off with A. So then, and then my determinant for B. Right. I'm assuming that obviously you've done a bit of matrix arithmetic at high school and also some time in your linear algebra class in math. So there's a condition that has to be met for a matrix to be invertible. There needs to exist a determinant, and the determinant must not be equal to 0. So since our determinants here, both of them are 11 and 78 respectively, therefore an inverse does exist. So I need to find the inverses for both matrices. So I'll type in this code, A, and then for B as well. So it clearly shows that there is an inverse that exists. So what I need to do now is to find the transpose for the matrices, also A, and then B, and I need to find the eigenvalues for both matrices. And I need to also show you that matrix multiplication is not commutative. So I'll multiply A times, yeah, and then multiply B times A. So you can clearly see that the different matrices that come up, right? And now I need to show you to do the LU decomposition of the matrices, which is as follows. And then for B, right? So when you multiply the two matrices that you get into in an L, let's say for instance in A, the two matrices in the LU decomposition, the lower triangular matrix and the upper triangular matrix. If you multiply the two of them, you get back your initial matrix. So what I'm going to do is I'll assign the following matrices. So A1, and then A2. So 1, 2. Right, and then A3 is what I would assign. And then now, just to prove that the matrices are the same, so matrix A, that's true. So basically what I've done is multiply these two matrices, this these two, and when I multiply them, I'll go the same matrix as A. Then just to prove that it's logically true, so A is indeed A3, so that's true. Yeah. So if you got any other questions, just hit me up at the bottom. Thank you, guys.